All right, now that we've created a couple things to dip your toes into AI, let's create a character that will patrol the area, use sight perception to chase you if they see you, and attempt to kill your character if they catch you. So let's go into our AI. Let's make a third folder, and I'm just gonna call this classic, classic horror AI. And we are going to create another character. So let's go to Blueprint class, character, and we will call this AI classic, why not? Let's go ahead and add our mesh and animation like we did with the other ones. So mesh, we'll just add our SK mannequin, bring him down -90, rotate him -90, and use the animation blueprint of just the regular third person and a VP. Okay. Which just has the built-in idle, walking, running, and jumping. All right, so we also want to make this guy a controller so it can run our future behavior tree. So let's right click, blueprint class, search for a controller, and we have AI controller right here. Select, and we will call this AIC for AI controller classic. We don't need to do anything inside of it yet, so we don't need to open it, but I will open my character, go to self right here, AI controller class, we need to change this to AIC classic. So now it is running through this controller. All right, so just like the last one, we need to now create a behavior tree and a blackboard. So let's go right click, artificial intelligence behavior tree, BT classic, just gonna call everything classic. Right click, artificial intelligence blackboard, and this will be BB for blackboard, classic. And if we open up our behavior tree, we can choose the blackboard that goes with it. We want the classic, so just select that and save. And we can also switch in between our behavior tree and blackboard like this. But let's go to our blackboard, and we are going to need a key of type vector, and this will be target location. Now, many AI tutorials you may see on YouTube will have your AI wander around randomly in a navigable area until they spot you and then they chase you. I don't really want their path to be random, because that can put them in some weird spots where they're staring at a wall or get stuck on the stairs, and it just looks a little less natural. So instead what I want to do is have them randomly pick a room out of our area to enter, and then spend some time in there, maybe randomly walk around in there. You could take it a step further and choose places specifically in the room you want them to go to and look at. But for this, we'll just be having them go into rooms, spending some time in there wandering around inside the room, and then choosing a different room just as a patrol. So let's go back to our behavior tree, and off of our root, we want a selector immediately. And the first thing we will have the two paths off is if our AI does not see the character and if it does see the character. For now, we'll just work on not seeing the character, so it'll patrol around. So let's create a sequence, and just to remind you, a sequence will go through all the different things in its subpaths in order, and we will call the sequence can not see player. Eventually, we'll add that blackboard decorator that will actually make sure it goes down this path when needed, but for now, we'll just leave it blank and come back to it. And leaving it blank will just also guarantee us that we'll always go down this path as long as we don't add something else to the selector. So we can just test it out like this. So first thing we need is a task for our AI to choose a random room to go into. So we'll create that task, new task, choose BT task blueprint base as an empty class. And if we go back, it creates it in the content browser. So let's create a new folder to hold them called tasks. And we will rename this BT find random room. Let's move it into our tasks and let's save. Now we need a way for the AI to actually select the rooms. So we're going to create an actor for this. right click, blueprint class, actor, and we will call this BP room target. We can open it up. Just so we can have a little visual of what we're looking at, we can add what's called a billboard, and we'll just be able to see this in the editor, but not in the game. You can change what the sprite is. I'll just use a default, I think they have one called target. Yeah, target icon. That's fine. And let's just add some of these in our rooms. So this room here will be one. I won't put ones outside the fences. So let's just drag one here into this room. Let's have this be a room. And let's have this be a room. Change it to unlit so we can actually kind of see in this one because it doesn't have any light. But right now our AI cannot walk through the door. I hit P to show you the navigation.
Hey everyone, Aiden from the future here to apologize. I skipped over a small part in the course where we didn't actually add the nav mesh bounce volume. So you see if I press P, it shows me this green area which allows AI to navigate and find where they can walk based on this green area. But if you hit P, it won't be there because we didn't add it. So if I scroll out, I have this big old box selected right here. Not this one, this is the light mask, but this one is the nav mesh bounce volume. So it's actually really simple. I'm just going to delete this one right now, and then all you have to do is search for it in here, nav mesh bounce volume, drag it in, and just make sure it goes over everything you want your AI to be able to walk around in, which for me is the whole stage. So I'm just going to scale it up this way, and then make sure it is scaled up this way as well. And then pressing P will just show you what becomes navigable. All right, back to the past version of me.
The door blocks it because it's a mesh with collision. So for the time being, I'm just going to be removing the door. And as you can see, it creates a path in between, and we'll add it in later. All right, I'm going to hit P again to get rid of the navigation, and we have our three separate rooms. So let's go into BT find random room. And as always, to start off, we have to get an event receive execute AI. So once this task is executed, we want to set our target location, which is the key we made in our Blackboard, to one of these three target room points. But what we want to do is set Blackboard value as vector. We need a key. We need to let it know that the key is our target location key. So let's promote this key to a variable, and we will call it target location key, and make sure it's editable so you can set it in our behavior tree. Otherwise it will not show up. And the value is going to be one of those target points. So what we're going to do is get a node called get all actors of class. And the class we want is going to be called room target, BP room target, which is this actor we created right here. Let's actually do that before we set the Blackboard key or Blackboard value. If I can put that in there. So this will get every single actor of this type of our BP room target in the world, which will return 3 different actors in an array, and we want to select one at random. So we will get a copy. So we're going to get one of these actors at an index. Right now they exist at indexes 0, 1, and 2, but we want a random one. So we will get random integer in range, and the min will be 0 and the max will be 2. But in case we want to add more rooms or more target points, we don't want to have to go back in here and change this manually every single time. So to get the max amount of them, we will just drag this off and get the length, which is the amount that there is in the world. But of course the length starts at 1, so right now the length will output a number of 3 when we need this to be 2, so we just have to subtract 1. Put that into max and put the return value into the get, and then this will output one of the 3 room targets, and we just have to get its location, so we will get actor location and put that into the value. And after that, we will finish execute, and we want it to be a success. All right, so let's go back into our behavior tree. Let's actually call that task. So it is find random room. And right here we have this target location key because we set it to editable. And we just want to make sure it's set to the right key. Of course, we only have one right now, but it's a good habit to get into to check. And we do want it to set the target location key, which is great. And then we just want to call one of the built-in tasks called move to. And it needs to know where to move to, which also takes a key, and it wants to be target location. So this task will save this value of the target location as one of the 3 room actors locations, and then we will move to that location. After he moves, it'll repeat to find a random room and then move again. So if we were to play it right now, the AI would not wait a split second before moving to the next one. So let's just add a wait node, which just adds a small delay before he goes to the next one. We can make this 3 seconds. All right, so let's test this out. It is a selector, but of course, since there's no decorator, it'll just automatically choose this one, and it'll play through this sequence. So if we take our AI classic, and let's just put them up here. Or let's put them in the back room, why not? And when we hit play, or instead of play, we can hit simulate, which means we won't possess our player. We can just watch what's happening in the world, which is kind of nice, and we can watch our AI. And he is not moving, and I know exactly why. It's because we never told our AI to use this behavior tree. And we do that in the controller. So we have AIC Classic, we open it up, event graph, and then in the begin play of this controller, we want to run the behavior tree. So the behavior tree asset is BT Classic, and that is all we have to do. Our AI Classic character already has the AIC Classic as its controller class. So this actor right here will know to use the behavior tree. So let's hit simulate again and see if it works now. So he chose room number 1, and then he will wait 3 seconds and choose another room. Chose this room and goes to that point, waits 3 seconds, and he chooses another room. Chose room number 1 again. So our AI will just do this forever, as long as we live. He seems to have a very heavy dislike for this middle room right here. Let's see if he takes it. Oh, he did. He came around. All right. And that is working very well at the moment. It works, but one thing we notice is he sprints very, very fast, and when he's patrolling, I don't think he should be in a hurry, since he's just walking around and doesn't suspect that anyone is in his precious building. But instead of just going to AI Classic, character movement, and changing the speed here, let's actually create a task for this so that we can change it dynamically inside our behavior tree. So when he doesn't see the player and he's patrolling, we can set it to a slower speed, but then he sees him, we change it to a sprint. So we will go to new task, BT task blueprint base, which is the base one. Go into our content browser and let's rename it BT set speed. Put it into tasks and open it up. As always, event receive execute AI. And we need to set the speed of our AI Classic. So we will get the controlled pawn and we will cast to AI Classic. The controlled pawn will be the object. As AI Classic, we can just get the character movement component, get character movement, and we will set max walk speed as whatever we want. So we will promote the max walk speed to a variable, and we will call this max walk speed, and we will make it editable so that when we call this task, we can adjust this number. After we set that. We want to finish execute as a success. Since we are casting to the AI Classic, in case this fails, which it shouldn't, we can just call a finish execute without a success, off cast failed. Okay, we can also change the max walk speed default to the regular default 600. Doesn't really matter as long as you remember to set it in the behavior tree. And speaking of that, let's go in there now. And when we cannot see the player, before we find a random room, we just want to set our walk speed. So tasks, BT set speed, we'll call this before finding a room. And because we made it editable, we can just choose the speed we want him to turn to. I'm gonna make it something like 225. So slow walk. And then whenever we add chasing the player, we will up it to 600. Now, 225 is a good speed, but the animation blend space we have for the character here isn't quite set up for that. You'll see if I simulate, he's going at 225. You see his feet are very floaty because the animation does not match up the speed very well. So this is kind of an unnecessary step just because, you know, this isn't about animation, but I'm gonna go ahead and fix it because it will definitely irk me. So let's find his animations by going to Content, Mannequin, Animations, and we have our blend space right here, third person idle run 2D. And he's got his 3 states right here. He is idle. Oh, if you want to move the preview value right here, you hold down shift while moving your mouse, and that'll preview the value. And I'm not gonna go into too much about how blend spaces work, but we basically have his idle state, his walking state, and his running state. And these are used at speeds. So if you could see the speed value that changes as I move the preview, this is the, to put it in the simplest terms, this is the animation he plays when he's at this speed. So right now, we set his run speed to 225. So if we move it to 225, this is kind of the animation he's doing, which is kind of wonky. We want it to be this animation. So we have to move this key to 225. We're also, in the future, going to make his sprint speed 450 instead of 375, so we can just adjust that too. So to put that above 375, we'll just go into horizontal axis over here. We're going to change the maximum axis value to, let's say, 500. Now you can see this is set to 500 instead of 375 because it's all the way to the right. And we need a few more grid divisions because if I hold and drag to change these, it snaps to these grids, and there isn't one at 225 yet. So I'm going to change the number of grid divisions to 20 so I can get a value at 225 and at 450. So I'm just going to drag these to 225 and the run speed to 450. Great. So now it should work. So let's test this out. He still moves at 225, but now the animation should be fixed. So he should just be able to do the walk animation. And there we go. It looks much, much better. But as you can see, if it kind of shows up, when he rotates, he kind of just snaps his rotation. We want it to be clean. Let's see if we can see it here. Yeah, see how he just instantly snaps his rotation to turn around instead of that happening over time? That is definitely something we don't want. So if we go to AI Classic right here, just go to self, and we have this Boolean checked called use controller rotation yaw, and we do not want that checked. So we go ahead and uncheck that. And then lastly, in the character movement, we can search for something called orient rotation and movement, and we do want that checked. So now when we hit play, his he should rotate towards the way he's moving over time. So you can see he kind of turns like that rather than just snapping his rotation, and it looks a lot more human. Probably look best once he gets down here and then turns around. So let's see what that looks like. All right, yeah, that looks great. Perfect. All right, so before we wrap this up, let's take it a bit of a step further and add a random reachable point in a radius. so that he doesn't always move to this specific spot in each room every single time. We can kind of add this radius, and he'll go to a random spot in that radius rather than just the center, so his location does not become predictable. Okay, so if we go into this actor, BP room target, we can add a sphere collision, and it's kind of small at the moment, but you can see it right there. We want to make sure collision is set to overlap all, so it doesn't actually block anything. And we can adjust the radius here, and we're just going to use a sphere collision to determine how far they can, how big the room is, essentially. So I'm going to go into the construction script, get the sphere, and get set radius, set sphere radius. And the radius will be a variable, so promote variable, just call it radius. Update overlaps can be checked, and we want to make sure radius is editable. So now, on each target point here, we can individually adjust the radius for what we want. You can definitely take it a step further and make it a box radius for wider rooms like this, so you can adjust it lengthwise, but essentially you don't have to worry too much about the limits of this sphere. So I'm going to worry about it in lengthwise like this. That looks pretty perfect to me, because we're going to set it up so the AI doesn't try to like walk over here where there isn't even ground, because we'll be using this navigable mesh to let our AI know the boundaries. So let's get this one, and let's drag it out a bit, and something like that is good. Maybe keep him outside the doorway. Yeah, something like that's good. And lastly, this one. And something, yeah. Maybe something like this. Okay, good enough. Okay, so now if we go to our BT Classic, we have this task, BT Find Random Room. We have to go into that, so you can just double click on it. And instead of setting our Blackboard value as the location of our random actor, we want to switch this up a bit. So let's move these out. And we're going to get a node called get random location in navigable radius. Okay, the origin will be the actor location of our random actor, and then the radius will come from our actor, and we will get the radius variable that we created. So if we go to BP room target, we created this variable called radius. It sets our sphere extent, our sphere radius, and I want to let you know that the sphere here on the actors don't actually do anything for our AI. They're actually just a visual representation for us. You could take the sphere out and just manually set up a float for your radius, but of course that'd be a lot harder to kind of guess how big the radius actually is. So this is just for a visual representation. So we get the radius and we just plug that into radius, and the random location that comes out of that will go into our value. Okay, so now our AI will choose a room to go into every time, but also should choose a random point inside each room. So let's simulate again, and let's see where he goes. So he goes into this room, and it's kind of in the center, kind of where the original point was. Same with this room. But what the node is doing, perfect example right here, is it's choosing a random point inside that spherical radius for the AI to walk to. So now it's not a predictable thing for each, for you to know exactly the location our AI is going to every time he goes into a room. Let's go ahead and check out the gate right here. So like I said, you could take this a step further if you want, just using the exact same technique inside of itself by maybe first choosing a room with a target point and having a second actor be, specific room targets where he could go inside the room and then choose something to go to specifically. And you can put one on the trash can, you can put one on this camera controller here in front of this poster, so that he would choose a room and then randomly choose like one of those three things to go to inside that room, so making it totally random. It's totally up to you, but since it's essentially the exact same technique, we won't be doing it in this episode, as it'll just drag on with me showing you the exact same things that we already were just doing. But this is a great start. We have our AI patrolling, and he doesn't do anything else other than patrol, but we will slowly but surely fix that in the upcoming episodes. Alright, thank you for watching. I'll see you in the next one. Let's give our AI a couple of eyes. We want our AI to start chasing us if he sees us, so we're going to give him sight perception. So first off, we want to open the AI controller. So let's go to AI folder, classic, AIC classic, and add a component called AI perception. AI perception right here. Now this is a great system that Unreal has built in, and we can add different senses for our AI to have. If we hit the plus button, it creates a new one, currently set to none, but we have these options: damage, hearing, prediction, sight, team, and touch. These are all different ways that AI can perceive things that happen in the world. So first, what we're first going to just use is AI sight configuration. We can also set this to his dominant sense, AI sense sight, although it won't matter too much for us. Alright, so let's open up 0 right here, sense, and it's automatically set us to sight. And we have our sight radius here, which is the maximum sight distance to notice a target, so 3,000 units in front of our AI. Our lose sight radius is essentially once our character has been spotted, the sight radius increases from 3,000 to 3,500, so it's a little harder to get away from an AI that's already spotted you than it is to actually be seen by an AI, if this makes sense. It also has our peripheral vision, which is how far to the side the AI can see. 90 might be a bit more realistic, but I'm going to change it to 45 to make it a little easier on ourselves. So he has a 45-degree angle of sight. Detection by affiliation, we have enemies, neutrals, and friendlies. We're not going to set up what is an enemy, a neutral, and a friendly to our AI, so we're just going to check all of these so it detects all of them. Because for our system, we don't really, he's not going to have neutrals or friendlies, so the only one it'll detect is you. And that's it for now. If we compile and save and hit play, if we hit the apostrophe button on our keyboard and hit the 4 button, we can now see the cone of vision that comes from our AI character. He's facing away from us now, but here we go. And it's kind of hard to see the range of his vision because it goes out so far that we can't really see it. So if we go to our controller and we change the sight radius down to something drastic like 250, so something really small. So if we try again and play and then apostrophe and then we hit the 4 key, should be able to see his cone. Oh, there we go. It wasn't working for some reason. The keys on my top weren't working, so I had to use the numpad to the right of my keyboard. Not really sure why. I don't think that's ever happened before, but it's working now. So we're getting this cone of vision. See if we can back up a bit. So you can see these 2 lines emitting from where he's looking. Oh. Okay, so this is actually something good to point out. He was able to go up there because that's in the circle of this room's radius, and I still have yet to put a collision on these bars. So once I do that, he will not be able to go up there because it will no longer be navigable. Same with these bars. but I'll get to that in a second. But you can see how his cone, this circle around him is the 250 distance we changed it to, and those 3 lines coming out of his face is the angle we can see him. So you would have to be inside that angle and inside the ring for him to be able to see you. You see that I walked in. It has a little sight meter, and it gives us the age, how long it's been there. But it only works if you're inside this cone and inside the ring. This is him seeing the other AI, but it doesn't really matter, distinguish between us, because he detects everybody, friendlies, enemies, and neutrals. So before we continue, I'm going to finally add collision on these, because I forget every single episode. So I'm just going to put a cube in here, and this is a pretty hacky way of just fixing it really quick, but I just gotta do it at this point, and then bring it back just slightly. And then I want to make sure the collision preset is set to block all, so everything is blocked. And then I'm just going to go to visible and uncheck visible. So now there is a collision there, you can see, because I can no longer walk through it. All right, let me just do the same for this real quick. Alright, and we finally added collision to these 2 fences, or gates I should say. Now the AI will not be able to walk up these stairs, even though it is in the radius, because if we hit P, you can see that it is no longer connected, so he has no way to get over there. Alright, so got a little backtracked there, but we still explained the cone of vision. We're going to go back into the controller, we're going to increase this back to 3000, so he has a good long ring of sight, and we need him to actually do something when he spots us. We need to add an event so we can actually do something after the AI spots us. So if you go to AI perception right here, right click, add event, and we have this one called on target perception updated. So when it perceives something successfully, this will be called. And the actor, we are just going to cast to L1 character, so that everything off here will only be fired if it's us that we perceived and not, for example, this guy right here. And we can test this by printing a string that just says AI classic saw character. And let's make the duration like 5 seconds, 45, whatever. We're gonna get rid of it in a second anyway. All right. So to even test it even further, we can hit apostrophe and then 4, and he saw the player. And you can see he's seeing us right now. We just went out of his line of sight because he turned around. I'm gonna undo the apostrophe so we can see the print string. Which doesn't look like it came up, so let's make sure this works. Oh, no, it did. So AI saw character, it's right there, and it continues to see us, and then we leave, and, you know, the string will stay up there for 45 seconds, so there's no use in waiting it out. But we know that we can successfully add code after the AI sees our character. So now that we know how it works, I'm going to actually decrease the sight radius to about 1000, just because we're in an interior, and then lose sight radius. It could be the same thing, or maybe something like 1250. Doesn't matter too much. And I'm gonna increase the peripheral just a bit to about 75, so it feels a bit more natural. And we need a boolean in our blackboard, so let's go to our behavior tree, go to blackboard, add a key of type bool, and this will be, of course, can see player. Boolean that will be in pretty much every AI you'll ever make. Just kidding, I have no idea. All right, so before we implement that in the behavior tree, we can just go back to AIC Classic and set it to true after he sees us. So we will get a reference to ourselves because this is the controller, and off of this we will get the blackboard that we are using, and we need to set value as bool, of course. And what key are we setting? Obviously we are setting our can see player. Now we need to type this in, so I'm just going to copy it and paste it to make sure I get it exactly correct. So off of key name, I will get a make literal name. Just allows us to type it in. and I'll paste it, can't see player. And we want it to be true, because once it sees us, we want the can't see player boolean to be true. Now, if we go into our behavior tree, we can add another sequence, and this sequence will be what happens when we can see the player. And now, since we actually have our bool, we can add the decorators. So I'll right click, add decorator blackboard, and I'll click on this, and the blackboard key we want is can see player, and we want it to be is set on this one. So if we can see the player, it'll go off this. Now let's do the same on this sequence. Right click, decorator blackboard, and we want the blackboard key to be can see player, and we want it to be not set. So if we cannot see the player, it'll go down this path. Of course, we need a way for us to, when the boolean is changed, go back up to the selector and select the other one, or in more proper terms, go back up to the selector and then check the boolean to go down which one. So we need to change the observer aborts to both on both. So first thing we want to do when it can see the player is we want to take this task, BT set speed, and we want to change the speed to 450. So it goes from a walking speed of 225 to a running speed of 450. Next, we need to get the player's location.
So unfortunately, some of the footage got a little messed up, and we don't actually have the part where I created this new task called find player location. But if we open it up, it's very simple. We just get our player character's actor location, set it to a blackboard value as a vector, just like the last one, and then we just tell the owner controller to do a simple move to location and finish execute.
The name of this is now a bit misleading. It's not only finding the player location, but it is finding and chasing the player. It takes in a key, if you remember, and we need that to be the target location, and it'll set that location and go to the location. All right, so we can test it out. So as soon as he sees us, he should chase us. So he's in the other room right now, wandering. And he sees us, and he switches to running and starts chasing us. And it is honestly quite terrifying, which is good because we were making a horror game. But yes, I was terrified, and I might have jumped out of my seat just a little bit. Lastly, let's just have him go back to wandering once we're out of sight, which is of course a little unrealistic. He wouldn't just immediately go back to his tasks if he no longer can see us, but we will get to a better way of working around that in a later episode. So let's go to the controller, AIC Classic, and we have the stimulus output right here, and we just want to break it. And this has a bunch of different parameters for our stimulus, like how long the stimulus has existed, the location, the receiver location, and successfully sensed. And we only want this set valuable can see player to true if we successfully sensed. So we'll get a branch off this. And for now, if it's false, so if it does not successfully sense our player, we're just going to set this bool to false. So I'm just going to copy and paste all this. Of course, we could do this with less nodes with a select node right here, but we're going to be updating this later, so it's fine this way. So we're just going to change the bool value to false if we are not successfully sensing the player. So to test this out, it's a little hard in such a small space because he chases you so well. So I'm going to change his run speed when he chases us to 225 as well, just so it'll be a little easier to get away from him because it'll be going slower. So you can see he sees us immediately and he's chasing us. But as soon as we get out of sight, he should go back to wandering. So I'm going to just go around him real quick, and I'm going to sprint up the stairs, and I'm going to get out of sight. And he's gone back to wandering. You see he's gone into the room, he's wandering, he's not chasing us. Of course, as soon as he sees us again, he will chase us, and the cycle continues. There we go, he's chasing us now. It's a little harder to tell when he doesn't switch to sprinting. As you can see, as long as we stay in sight, he will chase us no matter where we are. Alright, so that works really well. This is starting to become a much more fleshed out AI. That is it for this episode. In the next one, we're going to improve a bit of the switching back and forth between chasing us and patrolling to make it a bit more natural, a bit more human, since no one would just go back to patrolling immediately after that. So I will see you then. Alright, so obviously it's a bit awkward that our AI immediately gives up when you leave his sight, so let's have him investigate the area that he found the player in. So we need a new boolean for this, so let's go to our Blackboard where we can add a key of type bool, and we will call it isPursuingPlayer. So we have our two states, is pursuing a player and is not pursuing a player. And we can use the combination of these two booleans. So if we can see the player, we will always be pursuing the player. So if this one's true, this one also will always be true. But if we can't see the player, we can still be pursuing the player, which will put the AI in an investigative mode, or we can not see the player and not be pursuing the player, which is just in its patrolling state. So let's go to our behavior tree, and we need to add a selector above can see player. So add a selector, and we will call this is pursuing player. And below this, we will add the can see player. And we're going to rename the cannot see player to is not pursuing player. So we have our is not pursuing player, which is just the patrolling. And then if we are pursuing the player, we can either pursue when we do see the player, which is chasing him, or pursue when we don't see the player, which will be investigating. So for the is not pursuing player, let's change this Blackboard condition from can see player is not set to is pursuing player is not set. And let's add a Blackboard to this one, add decorator Blackboard to is pursuing player is set, and observer aborts will be set to both. So now we just need to add a path for if we are pursuing the player, but we cannot see the player. So let's add a sequence, and this one we will call what the last one was called, cannot, oops, if I can type, cannot see player. And let's add a Blackboard, decorator, Blackboard, and we've already added this, can see player is not set, observer aborts both. So what do we want our AI to do when we are pursuing but cannot see the player? First, we want the AI to go to the last location that they did see the player. So let's add a task for that. So new task, BT task, blueprint base. Go into our content browser, AI, classic, and here we have our new one. We'll just call it BT last player location. Having trouble with that caps lock today. Put it into tasks. I'm going to close a few things that we don't need. So here we are in BT last player location. As always, receive execute AI. We will cast to the L1 character, which is of course the character we're playing. Object will be get player character. And we just want to get its location, and that will be set as the last seen location. So what we will do is set Blackboard value as vector, and we're going to set the target location key. So promote key to variable, target location key. Very important to remember to make it editable. And then as L1 character, we will get the actor location, and that will be our value. And let's just add a finish execute here with a success to true, and on cast failed, a success is false. Okay, so let's put this in our behavior tree. So last player location, and we want to make sure the target location key is set to target location, which it is. And then we just want to move to this last location, so we will get a move to, and we want to make sure the Blackboard key is target location again, so we move to our character's last location whenever this is run. And before we start searching, I want to set his speed from running to walking, so we will get the task, set speed, and I'm going to change it to 225. And we never changed it back to 450, so I'll do that now for when we can see and are pursuing the player. So we set it back to walking once the AI is just looking for us. Now we need a task just to search around a little bit for the player. So we will add a new task, BT task blueprint base as always, content browser, rename it BT search for player, put that in tasks and go into it, execute AI, and what we want to do is just have it look around in a radius from where we last saw the player. So we will first set a Blackboard value as vector. Just get this out of the way. The key will be the target location key, editable of course, and the value will be a random location inside a radius based off the player's last location. So we will get the node get random location in navigable radius, and the origin will be our target location key, and then get value as vector, because our target location is already set to the player's last location. So we'll use that as the origin. For the radius, we can promote this to a variable. We'll call this search radius, and we'll make it editable, so we can just make it whatever we want inside the behavior tree. As default, I'm going to set it to 250. And after we're done, we want to make sure the random location is plugged into the value for setting the new target location, and then once we're done, we will finish execute with the success being true. Okay, so I also want our AI to search for the player a total of 3 times before he gives up and goes back to patrolling. So after setting the speed, we want to add another sequence. And we're just going to call this loop search. I can spell. So we're going to add a decorator to this, but not of type Blackboard, it will be of type loop. So this will loop this sequence a certain amount of times. So we click on the Blackboard, we can choose how many times. It can be infinite, which we don't want, or we could just choose a number. And I'm going to keep it at 3, so we do whatever is in the sequence 3 times before it goes to the next, or if there is nothing next, goes back to the beginning of this sequence right here. So the first thing we want to do in this loop search is call our search for player. Make sure target location key is set to target location, and we can change the radius if we want. And then after we find a location in there, we want to move to that location. So make sure the move to is set to target location. And then we want to wait a couple seconds to make it feel more natural. So let's say I want him to wait anywhere between 2 to 4 seconds. We can make the wait time 3 with a random deviation of 1. So it'll go anywhere between 3 minus 1 and 3 plus 1. So anywhere between 2 and 4 seconds. And then it'll loop back around. After the loop is done though, we want to give up is pursuing player. So we need a new task for that. So new task, BT task blueprint base. Go into content browser to rename it BT set is pursuing. Move it into tasks. And as always, execute AI. And we're just going to set Blackboard value as bool because we want to set the is pursuing player to be false. So we want to promote the key to a variable, and we will call it is pursuing player key. Make it editable, and then I'm going to promote the value as a variable as well, make it editable, so we can use it to both turn on and off the is pursuing variable. Then it will finish execute as a success, and that is all we need to do in there. So let's go to the behavior tree, and after we loop 3 times, the next thing we want to do in the sequence is give up. So if we go to tasks, and we can set is pursuing player key needs to be is pursuing player, and the value we want to be is false. So the value is false, is pursuing player becomes not set, so it'll switch back to is pursuing player is not set, and come down here and continue patrolling. Now, one last thing before we continue is go back to the AIC Classic, and when we see him, we need to turn on is pursuing player to true. So we can just duplicate all of this. Oops. Which is, on target perception updated, successfully sensed. We set can see player to true. We also want to set is pursuing player to true as well. So let's go to Blackboard. I'm going to copy and paste just to make sure I spelled exactly right. So both of those are set to true. And then when we stop seeing the player, can see player is set to false, but is pursuing will stay as true so that it can go down this path, and if it doesn't find him in this time, is pursuing will be set to false. So to kind of show you how this works now, I'm gonna separate these just a bit more. Oops. It's a little easier to see what's going on. And I'm gonna pull this to the side. You won't really be able to read what's going on, but if you can remember the positions, we're going to play, we're going to watch what's happening. So he chases us immediately, and once again, I'm not going to lie, it kind of scared me a little bit. So I'm going to start down here instead of up there. So we can see he's patrolling. And we got to see if we could find a way to get him to see us, and then get back out of sight. So he should be able to see us from there. And then if we can get out of sight, he goes to our location, but then he saw us again immediately and came back to us. So what I'm going to do is when he's chasing us right here, I'm going to set the speed back to 225 to make it a little easier on ourselves. And let's try this again. So he'll only walk. So, in fact, I have a great idea. Let's pull in, let's go to Blueprints, Actors, and hide actors. So let's pull in this locker, and we'll hide in here for now. So what we're gonna do is we're gonna spawn right here. You can see in there he's wandering around. Now if we can get him to see us, he's chasing us, and if we can get out of his sight, if you see in the lower left there, he is patrolling. So I'm gonna actually eject out of my player, and let's find where he is. And he went to the last seen location, and right now he's waiting, and then he should, oh, I think we missed it. So I think it did all 3 when we weren't looking. So let me try this one more time, see if we can do it a bit faster. So let's have him see us. He's chasing us, he's chasing us. Now he's searching for us by going to the last location. Shift F1 and eject, and watch him. So we went to the last location. He's waiting for the 1 to 3 seconds. He's searching again. He's looking around. I don't know if that was 2 or 3. That was 3, and he has given up. So he's going back to his patrolling. So this actually works really well. He searches around for us. when we look. You can make the radius a bit bigger because it just kind of takes a few steps left or right. And if you wanted to do that, you would just come to right here, search for player, increase the radius to have him look around for us. If you want him to look around a little longer, you can loop it up to 5 times, and we can kind of see how much customization we're starting to get over our AI, which is really great. Shift F1, I will eject. It's going to the last seen location. He waits. He looks around. He chooses a random spot inside that radius. Chooses a random spot. That was 2 or 3. Let's see if he chooses another random spot. He's looking around for us. He knows we're around here somewhere. I think that was the last one right there, and he should go back to patrolling. And there he goes. He has given up. All right. So now we've made it a bit more realistic for the AI to search for us, which is really great. That's going to be it for this episode, and I will see you in the next one. This is going to be just a really short episode. I thought it would just be kind of fun. I forgot to put it in there if it played that jump scare noise we had when he spots you. So I thought it'd be kind of cool to show you how to play that sound. So it's very, very simple, so this will be very short. So essentially, what we have here is when he's pursuing the player and can see the player, this is when he starts chasing you. I'm going to set this back to 450 so it's clear to tell when he chases you, just like that. But I want it to also play a noise. So we'll have to create a new task for that. So new task, BT task blueprint base, AI classic, here it is, BT play jump scare audio. Move that to tasks, and in here it's just as simple as execute AI, and we're just going to play sound 2D, and the sound we want is our jump scare sound that we already have in the game. And now if we were to just finish execute like this, success, and go into the behavior tree, we would want to put it under is pursuing player, can see player, because this is where we set speed and chase the player. I would just maybe put it first. So play jump scare audio, but don't do this because, oops, didn't even do that. If you remember, a sequence loops, so which means it's looping pretty much every frame, which means this audio will play every single frame, and it is not a sound you want to hear if you value your eardrums. So what we need to use is what's called a do once node, which means it'll only do whatever's after the completed one time, unless we call this reset node right here. Now, the only issue is it's everything after the do once will only complete it once, which means after the first time, this finish execute will no longer be called. So instead of putting it there, we need a sequence which just executes a series of pins in order, break the finish execute, and put it under here. So no matter what, we will always finish the execute, even if this do once is already blocked and we no longer play the sound. So now, when we see the player, it should play the jump scare audio just once. We set the speed and we chase the player. So let's test this out. He sees us and it plays that sound. Perfect. Now we have one other issue. I'll demonstrate by putting his speed back down from when he chases us, so it's easier to get away from him. Let's have him see us. He sees us, and he's chasing us. And we are definitely out of his sight right now, so he's going to investigate. He sees us again, and we have no sound. That's because it is a do once node. So we need to find a way to reset it. And the easiest way to do it is just go in the blackboard, and we're going to add a third boolean, or our fourth key. And it'll just be called play jump scare audio. And we want this to be true by default. So if we go to our controller, off of begin play, we can just get the blackboard, set value as bool, and key name will, sorry, not promote to variable. We want to make literal name, and you know the drill by now, copy and paste. And we want the bool value to be true. Then in our play jump scare audio, we can switch out this do once for a branch, and we just have to check if that boolean is true. So get value as bool, and we need to promote this key to a variable as always, so we'll call it what do we call the key? Let me check. Play jump scare audio, so we'll call it play jump scare key. Set it to editable and put that into the condition. So if play jump scare is true, then we will play the sound, and if it is false, we will do nothing. This way we can set it back to true once we go out of sight. And luckily we don't have to create an extra task for that. We can just go back into AI Controller Classic and see how we have this set value bool can't see player to false once he goes out of sight. We can just copy this play jump scare audio and paste it in here, so once we go out of sight, our jump scare audio will be set to false, which means once we are seen again, we will, set this back to true. So once we are seen again, it'll play again. What we also need is to set it to false under successfully sets true, so that it doesn't play multiple times. So we definitely could have just created a task for this and put them in here as well. It doesn't really matter in the long run, just whatever you want to do, but let's just recap. We set play jump scare audio to true in the begin play, because it's the first time we want to play the audio when the AI sees. But once the AI sees as well, we set our jump scare audio to false, which now I'm thinking might actually have to be in a task, just in case it does it before this task is called. And then once he doesn't see him again, we set it back to true. Actually, yeah, you know what? Sorry for a bit of the mess, I just realized it'd probably be a much better idea to get rid of playing jump scare audio, setting to false in here, and setting it to false in play jump scare audio. So after we play the sound, we will set value as bool. The key will be jump scare key, and we will set it to false. That way we should be steered clear of any bugs. So just select this task, make sure the jump scare key is set to play jump scare audio, and let's recap just one more time. Sets to true at default so that when we start it'll play the audio. Once it plays the audio, it sets it to false, so every other time this sequence loops over and over again, we skip playing the audio so it doesn't overlap itself. And then once the player goes out of sight, we set the play jump scare audio back to true so that once we come back in sight, it will play the jump scare audio again. So every time he sees us and start chasing us, it'll play the audio. So let's test it. He sees us and he's chasing us. And if we can go out of sight, once he sees us again, it should play. There we go. Of course, it'll be a little creepier if his speed is 450. I just keep changing it back and forth because on such a small map, it can be a little difficult to actually get away from him. Out of sight. So he'll investigate for a while, but if we leave, he sees us again and starts chasing us. So that's personally much scarier because, loud noise. What else can I say about it? But now we got a jump scare audio playing every time he sees us and starts chasing us. So obviously we want our character to attack us when he gets near, rather than just kind of push up against us forever, as he does when he runs after us. There are two ways we can do this. One is more of a survival horror way, and the other is a bit more of a classic horror way. The classic horror way will whip you around to face the enemy as they play their attack animation, which kills you. The other won't restrict your movement, and if they hit you, it does damage, but you can continue to run away. We're going to set it up in the classic way, where he kind of whips around and kills you, because if you want to do the survival way, where he just kind of hits you, but you can keep running and it just takes health away, you can just skip the part that will freeze and rotate your character, and instead of killing the character, you can replace that code with just taking health off, and we already went over health. So first off, we're going to need an attack animation for our project. I'm going to use an animation from Unreal's Paragon assets they give away for free. So if we go to Epic Games, and then Marketplace, and then we search for Gideon, which is a character from their Paragon assets. This character has 201 animations included, and we are going to use one of his attack animations. So just go ahead and download it, and then you can hit add to project, and then choose the project you want to add it to. Alright, and once that is done, we should get a folder somewhere in here. Here it is, Paragon Gideon. And if we go into characters, heroes, Gideon, animations, we have all his animations right here. And the one I'm going to use is primary attack A medium. So if you look at it right here, we can open it up and watch it. So we have it open right here. Some of the textures, the shaders need to compile, which is why he has a lot of default materials, but we just have this kind of punch material. Maybe he's doing some spell, I'm not sure exactly, but it's going to work well enough for what we want. So what we have to do now, since we're not using the Gideon character model itself and just the animation, is we have to retarget the animation onto the mannequin. I have a more in-depth tutorial on retargeting animations on my YouTube channel, CobDev, which you can see the link at the bottom of the screen. So you can go check that out if you want a bit more detail on that. Alright, but let's go ahead and get to retargeting this. So we have this attack open. Let's go ahead and click on the skeleton tab right here. So we just opened his skeleton. And let's also open the skeleton for the mannequin. So I'm going to click content, close the search, mannequin, character, mesh, UE4 mannequin skeleton. So we have the two skeletons right here, and we just need to go into the retarget manager right here. If it's not there, you can go to window, retarget manager, and down here where it says select rig, we want to choose select humanoid rig. Choose that right there. We also, and we can save it, we also want to do that in the UE4 mannequin. So retarget manager, select rig, humanoid rig. Luckily with the Paragon asset, this is our only step because it can automatically match all the sources and targets together since it's a UE4 created skeleton. But for many other skeletons you might work with, it could be a lot more complicated, as these won't automatically choose all the exact bones it needs to. So if you're having trouble, or if you ever plan to do this with other skeletons, it would be a good idea to go check out that YouTube video on my channel. Now in the mannequin, it should also automatically, yeah, everything looks good. You can see everything matches up. If you needed to change anything, you would just select it and choose it, but just make sure it matches. So luckily it's a little easier for us here. So if we go back to content, Paragon Gideon, characters, heroes, Gideon, animations, and we could find that animation again, attack, primary attack A medium, and you can do this with any animation you want since the skeleton now matches up. Any animation should work, but we can just right click and choose retarget anim assets and then duplicate anim assets and retarget. We now have this option here on the left that wouldn't have been there before if you hadn't done this first step, which we can select, and you can see the source, which is our Gideon, and our target, which is the UE4 mannequin, and we can go ahead and click retarget. So now it says primary attack A medium duplicated to game/mannequin character, etc. And it puts it right in our content browser, and we open it up, and we can see now we have the Gideon animation on our mannequin. So luckily, this went very smoothly. All right, but we only need this animation from the mannequin's waist up because he will be walking and running, and we don't want his feet to just start sliding around like this as he moves around when he starts the animation. This step might only be necessary for the people who will be doing it where he continues to chase you while he hits you and it just does damage and nothing is locked into position, but just in case we'll do it for our classic as well, even though he will be stopping to hit you because you will be locked into the animation. So to do this, before we start, let's drag it into our mannequin. So I'm going to click this sources panel button right here so we can just kind of get a list view of everything. I'm going to open up mannequin, and I'm just going to drag it into mannequin animations, which is the same folder as just going here, mannequin animations, and now it is here, primary attack A medium. So to get this from the waist up only, we are going to right click and we are going to create a anim montage, and we can just leave the name as is, and let's open that up. And we're going to go over here to where it says anim slot manager. If this is not here, you can go to window, anim slot manager, and we're going to add a slot, and the slot is going to be called upper body. And then we just want to make this animation set to upper body. So right here it says default group, default slot. We want to change it to default group upper body. All right, so now let's open up our blueprint. So let's go to horror level and then content mannequin animations. We have it right here, third person anim BP. And by default, it already has a few things. It has this state machine that allows him to go from idling and running, and then a whole part where he jumps. So if we go to the anim graph right there, we need to create a node called layered blend per bone. And we're going to plug that into the result. So we have our base pose, and that's going to be this default state machine. And if you double click inside the state machine, this is this idle, jump, and run state machine, which just controls whether he's idling, running, or jumping. It's all set up for us. We don't need to mess with it. If you want to go back, just click anim graph right here. And the blend pose is 0. We want it to be the same thing except with the attack montage blended in from the waist up. Now, unfortunately, we can't duplicate this state machine, and we can't put it into two separate nodes. So we have to cache it as a reference. So drag this off and just search for cache and new save cached pose. And then we can name this, and I'm just going to name it default pose. Then we can call default pose. So use cache pose default pose and plug it in like that. And this one we can duplicate and use as many times as we want. It's kind of like storing this state machine as a variable. Now for the second blend pose, we want to pass it through the slot upper body. So we can just search for slot and it'll default to default slot. So we want to change it to upper body and then put that into blend poses 0. And the bone we want to blend by is the waist. So everything above his waist bone here is where we want to blend that attack animation. So we go to layer setup, to select this node, layer setup, 0, branch filters, add element, 0, bone name. And we need to make sure the bone name fits the exact bone name in the skeleton. So we can go back to the skeleton and just check where we want it. We're going to be using spine 01, so everything above this bone. So you can copy and paste if you'd like. I'll just type it in, spine _01, and that's all we have to do right there. So now our animation should be working properly. We need to check if our enemy is close enough to kill our player next. So we will do this with what is called a service. So let's go into our behavior tree for our AI right here. And we're going to go to Blackboard and add another bool. And this is going to be can attack player. If I can type in that incorrectly. And we're going to add a service, new service right here. And it's going to work similar to a task. It's going to create a new one. We have to go back into our content AI classic and rename it right here. So I'm going to call it BTS is close to player. And this is just going to check if we're close enough to the player to attack him. So I'm going to create a new folder called services and put it in there. I'm also going to close all these other tasks that we don't need anymore. So it's going to start out almost the same with a node called event receive activation AI. So when it's activated, and what we're going to do is get the distance from our AI to our player. So we have our control pawn here, which is the AI it's controlling, and we are going to get actor location, and we will use a node called distance vector. And for vector 2, we're going to be using our player's location. So we will get player character and get actor location. And that'll be our vector 2. This return value gives us a distance of how close or far the AI is to our character. So at first, we're just going to print this result as a string. So put that into in string, it'll convert it for us. For duration, I'm going to use get world delta seconds. So it essentially will just play once per frame, so it won't flood the entire left side of our screen. All right, so let's go back to our behavior tree. And to test this out, we're going to put our service on the can see player path. So it's only going to tick if we are close to the player, and check the distance if it is pursuing and can't see the player. We don't really need it when he's investigating or when he cannot see the player. So we're going to right click, add service, and we have these two default ones, and then we have the one we just created, BTS is close to player. And we can choose how often it ticks and the random deviation of that, so it'll tick every 0.4 seconds to 0.6 seconds. I think that's fine as a default. And now, since it prints the string, when he sees us, it'll be able to tell us how close he is. And before we get started, I'm once again going to set his chase speed to walking, so we can have a bit more time to kind of look at that distance. So once he sees us and starts chasing us, we should get a print string in the upper left showing the distance. Yeah, there it is. So you see as he gets closer, it goes down, and we got to find a number we want when he of the maximum length it can be before he attacks us. So let's keep an eye on it. And let's say I want him to attack us at about that distance. So maybe like 125 or 100 looks about right. Of course, it goes so fast, it's kind of hard to tell. It's kind of flashing when I use get world delta seconds, so I can just delete it and have it flood the left side of the screen if I want. And where'd he go? There he is. And then, let me see. Yeah, maybe something like 125. So let's go back to the service. And we just have to now check if this distance is less than or equal to 125. So we will get a less than or equal to float by float. And for our number here, we're going to promote this to a variable, and we are going to call this distance to attack. Make it editable. And the number will be 125. This is so in the behavior tree, we can adjust it if we want fairly easily. We'll get a branch right here. Actually, we don't need a branch, because what we're gonna do is set value as bool, set Blackboard value as bool, and the key we'll be setting is our new can attack player boolean. So let's promote it to a variable. Call it can attack player key. Make it editable, of course. And the value will just come from this boolean right here. So now in our BT Classic, this service will tick and this boolean will change accordingly, whether it can or cannot attack. Of course, we have to change the can attack player key to our can attack player boolean, and the distance to attack we can adjust as needed in case we don't like 125. So of course, once this boolean is changed, nothing will happen in the world, so we need to actually create an event for that. So let's go inside our character, our AI Classic character, and let's make a custom event, and we will call this kill player. First thing we want to do is play a montage, and the montage we will be playing is the montage we created, the primary attack A medium montage. Make sure you're choosing the one for the mannequin and not Gideon's. They're called the same thing, but I can kind of see in a little preview here that that's the mannequin and this one's Gideon's, so choosing the mannequin one. And then the in skeletal mesh component is just our mesh right here. You can adjust the play rate, how fast the animation plays, or the starting position, but for now, this is all good. We also need to whip our player around to view the camera, or to view the AI, sorry. When this happens, of course, if you're making the survival type, you don't have to do this part. You would just play the montage, and then in our player, you would just apply damage instead. If we go into Game BP, level 1, L1 character, event graph, we can create a new custom event for this. So we'll do it down here, custom event, and it will be called caught by enemy. And of course, if you want to do the type where it just takes health, all you have to do is take out BPC health and call the remove health function, and then just type in an amount, and that would just take away some health. But for the more classic type, we need an input to this called enemy, and this will be of type pawn object reference, so you know what enemy caught us in case there are multiple. First off, we will disable movement from our character movement, get player controller. We need to disable look input. Well, disable input, we need that as well. Make sure the player controller goes into the player controller, not the target. And then get look input and set ignore look input is what I meant, and set that to true. Then we want another custom event called rotate to enemy. And this is going to be called on a timer, which is why we need it as a second custom event. So back here in caught by enemy, we will set timer by event, and the event we want is our rotate to enemy. We can set our time to something fairly low, like 0.01, and choose looping to true. And this is where we actually need to rotate our character to look at the enemy, so the enemy can attack us. We will get the player controller, and we're going to set the control rotation, and we're going to use our handy dandy find look at rotation node. The start will be our location, so get actor location, with the target as self. And the target will come from the enemy that attacks us. So we'll drag off enemy, get actor, location, and this is our target. And the return value will be the new rotation. Sorry, not directly the new rotation, because we need to interpolate it over time, which is the whole point of the timer. So we are going to get a R_interp_2, or rotation interp_2, and this will be the target. The current will just be our player controller, and we will get control rotation. So whatever our current rotation is, that's the current. Delta time will be get world delta seconds. And our interp speed can be whatever we want. How fast it's going to be, I'm just going to choose 10. Now we need to end this timer once we are fully looking at the character, so it doesn't just go on forever. So we will add an if statement or a branch after set control rotation, and we just need to get the control rotation. So I'm going to copy and paste get player controller, get control rotation. And we want to see if this is equal to this find look at rotation node. So we will get a equal rotator, and we'll ask if it's equal to this find look at rotation to see if we successfully turned all the way. And then this is the tolerance, the error tolerance, and we can just make it something like 1 degree. So we'll always get a success. Put that into the branch. So if this is true, we want to stop the timer. If it's false, we do nothing because it means we are still turning. So if it's true, we got to clear this timer, and since we set it by an event, we don't have the option just to call clear timer because it only has clear timer by function name. We have to clear and invalidate timer by handle, and the handle comes from the output of this set timer. So it knows that this is the timer we need to clear. After we finish rotating, we want to call that custom event from our AI classic kill player so it plays the montage, but we won't only want to do it once because it'll start to overlap itself. So if we call a do once node, and then off of completed, we want to play that montage, so we have to cast to AI classic, which is our AI. The object will come from this enemy right here. We can use a reroute node to clean this up a bit. And then as AI classic, we need to get the custom event, which is called kill player. So we will just call kill player. Of course, we want to reset this do once node because if we restart the game, it won't stop if you do restart it within the game itself. So once we are caught by an enemy again, this will reset. This is the easiest way to just reset that. So we will call a sequence. The first thing it will do is all this, and once it's done setting the timer, since that's the last thing in sequence 1, it'll then reset the do once node. So if we are caught by an enemy again, it will once again be able to kill the player. Okay, so I think all that is set up. Try to get in a good habit of commenting things out, so we'll call that caught by enemy, since this whole thing became kind of a mess. Now we just need a way to actually call this custom event because nothing calls it at the moment. So let's go into the behavior tree, and we need a new selector. And this selector is actually going to be the new can see player. So we're going to call it the same thing, can see player. And we're going to channel it like that. We're going to move this blackboard condition to here, same with the service. And this one is no longer can see player, but it's can see player plus player, cannot type, player is out of range. And then we need a new sequence off of this called player in range. So if we are pursuing the player, we can see the player. We have two more options after this. If it's out of range, which means we chase him, but if he's in range, then we kill him. Of course, we need a blackboard selector for this. Decorator, I mean. So add decorator, blackboard. And the condition is if can attack player is not set, which means we are out of range, and then observer reports will be both. And if it's in range, we add a blackboard decorator, and this is if can attack player is set, and observer reports will be both. So first off, we're going to set the speed. We're going to set his speed to 0, so because we want him to stand still. And then we are going to call a new task for killing the player. So create a new task, BT task blueprint base. Go back into AI, classic. We're going to rename it BT kill player and put it into tasks. Open it up. As always, event receive execute AI. And we just need to go into our L1 character, and we're just going to call this custom event caught by enemy since we have it all set up in there. So cast to L1 character, get player character for object, and as L1 character we call caught by enemy. The enemy we are caught by is the controlled pawn. Then we will finish the execute. Oop, not finish abort. Finish, execute, success will be success. We can also put one under cast failed with success as false. And compile and save. And let's add it to our behavior tree. So back in the behavior tree, we set the speed to 0 if the player is in range, and then we will kill the player. Now, since this is a sequence, as soon as kill player is called, it's going to go back to set speed and call kill player over and over and over again, and it's just going to start repeating itself, which can cause bugs. So since he is killing the player, we are going to call another sequence with a wait node in it. The wait can be whatever time you want, as long as it's above 0. And then we're just going to right click, add decorator, loop. And the loop is going to be infinite. So it'll just infinitely loop this wait sequence because our player will be killed. What you also can do is figure out the time it takes to kill the player in case you're making something multiplayer, or you definitely wouldn't want this if you're doing this system where he just attacks you and takes health away and you don't get locked in the animation. This is just if he kills you and the game ends. But you can definitely just add a wait node for how long it takes to kill the player and then send him back to the patrolling mode or something like that. But for now, we're just going to have him wait infinitely. Okay, so let's test it out. So what should happen is he patrols because he is not pursuing the player. He then sees us, which changed him to pursuing player and can see player. We will be out of range when it starts, so he will play jump scare audio, set speed to run, but right now it's set to walk, and then chases us. And then once we are in range, we set the speed to 0, kill the player, and then loop an infinite wait so that he just stays there forever. So let's test this out. What it also should do is disable our movement, disable our input, and make us look at the enemy, and then the enemy should play his animation. So let's test this all out. So when the enemy sees us, we're going to turn around and see if it rotates correctly when it catches us, which it does. There we go. We can no longer move, we can't look around. He has killed us. We obviously need some kind of fade to black and game over screen. Let's test this again to make sure the distance looks good of his range to kill us. So he kills us when he gets that close. We can adjust this if we go into our BTS is close to player, and we can change distance to attack. Let's do something drastic at first, like 500. So let's try that. And he can kill us from that distance, which of course is absurd. So I'm going to change this back to 125, because I think that worked pretty well. Okay, so before we wrap this up, let's just create a fade to black and a restart button, since it should go relatively quick. So let's go into UMG, and let's create a new widget called W Game Over. Open it up. We're going to add a image, anchor it to the full screen with all the offsets at 0, and let's just tint the image completely black, and then we can add some text in the center, just doing this relatively quickly. So center, position X and Y both 0, alignment 0.5 and 0.5, so it's perfectly centered. And size to context, I'll just set that to true, so the size will be however big it needs it to be. And I'll just type in game over. Just gonna zoom in a bit so we can see. Make this size something big. Let's use our Calibri font maybe in bold. Sure, something like that. And then I'm gonna add a button below it. So anchor to the bottom middle, alignment X 0.5, and position X 0, 0. Well, let's make that something like -200, and we can increase the size of this a bit, something like 150 by 600, and then I'm gonna drag it up a bit more. Okay. I'm gonna add some text on top of that button that just says restart. Make the text black so you can see it, and maybe a little bigger. All right, so something just kind of quick. Now let's make an animation to actually like fade this black in. So let's press animation, we'll call it fade in. If we select fade in, we can add a track. So let's select the image, which is our black background image, add track, and we'll have it right here since we have it selected. And now that it's in our track, we can add a track specific to the image, and we want to add one for render opacity. So let's set render opacity to 0 at start, and then let's go to 1 second and make the opacity 1. So it just fades in over the time of 1 second. And then after it fades in, let's fade in the game over and restart buttons. So let's add the game over text to the track. Here, our text right here, and then the button as well. So now we have our button, image, and text. Actually, let's just rename these so it becomes a little less confusing. So black background, game over text, and restart button. There. Now they're named correctly, and it'll make it a bit easier. So we already have our black background, fade in over 1 second. I'm gonna add another second and just add another key, so nothing happens within this second. And then over the second to third second, I will second to third second, I will fade in the game over and restart. So at the beginning, the restart button, add track for render opacity and set it to 0, and then the same with the game over text, render opacity 0. Now once we get to 2 seconds, I'm going to add another key for both of these. So game over text, add a key, which is still at 0. Restart button, add a key, still at 0. And then at 3 seconds, I will increase these to 1, which will add the key automatically, and add the keys to 1. So we can play the animation just to test this out. I'm gonna hit play, fade to black, and then the buttons fade in. Okay, perfect. So something really simple. You can do whatever you want with this. I'm just trying to do something kind of quick so we can wrap up the episode. So let's go to the graph, in event construct, which is essentially the same as the begin play. We will just call play animation. The animation will be this fade in animation we just created. Start time 0, so it starts at the beginning, number of loops to play 1, play mode forward, etc. And then when we press the restart button, so on released, we just want to restart the level. So we will do this by getting a open level, and it needs the level name. So we will get current level name, and that will be our level name. So we just know to restart whatever level we are currently inside. Cool, so now we just need to create this widget once our enemy kills us. So if we go to our AI classic character, we have this kill player play montage, and once the montage is completed, we can create the widget. And then it's W game over, and then we will add to viewport. After that, we want to get the player controller, and we want to set, show mouse cursor to true so that we can click on the button. And then we also want to set input mode to UI only, so we can easily interact with the UI without accidentally interacting with anything in the world. We can choose a widget to focus, which will just be the game over widget. Alright, so this should work, but as you can see, I'll just show you. I'm gonna have him catch us. And creates the widget, fades to black, and the buttons fade in. Perfect, looks good. And if I hit restart, it should restart the level we're currently in, which is level 1. And it does. Now there's one issue here, and that's that we are inside the floor. And that is because we don't have a player start. So if we come over here to the left, if you don't see it, you can just search for it, player start. And just drag it wherever you want the player to spawn in on the world. And we've just been spawning in at the current camera location, but you can change it here to default player start, and now we will start in that location no matter where our camera is. See? And it should work again when we restart the level. Restart, and we are in that location. But we have a problem. We can't move and we can't look around because we disabled that. So let's open our level blueprint. So go here to blueprints, open level blueprint, and we have our sequence. We have our begin play here, sorry, and we want to create a sequence so we can do things in order. And all this post-process stuff we did, I'm going to move it to the second one. Before we do that, we're going to enable all the input and everything. But instead of typing it all out, I'm just going to copy and paste it from our toggle inventory. So if we go to our content, game BP, player controller, we have our toggle inventory custom event, and we have all these things like set movement mode, reset ignore look input. So I'm just going to copy and paste this. So get player character, character movement, set movement mode, reset look ignore input, show mouse cursor to false. We're going to have to replace this inside of it though. And set input mode to game only. So copy and then go into our level blueprint and paste. And then we'll just move this over here. So first off, we set our movement mode to walking, so our movement is re-enabled. We reset our look ignore input, but that comes from the player controller. So get the player controller and put that in for the target. And we will also have to grab the show mouse cursor from player controller. So set show mouse cursor to false, and then we have our set input mode game only, which also comes from our player controller. Okay, so now the begin play will be called every time that we begin play, so it'll just automatically throw this in here, and it should also work when we reset the level. The begin play will be called once again. So let's have him see us and attack us. And we hit restart, and we can move and look around, and everything should be working. Perfect. All right, we have a functional way to get caught by our enemy and restart the game when he kills us. There's only a few things left to make this a bit more fleshed out. And next episode we work on hiding. So we want to make it so if our AI sees you go into something like a locker, it is not a failsafe, and he'll open the locker and attack you. Because it's a little disappointing if you can just hide in the locker while he's chasing you and nothing happens. And what else we got? And we need to have the AI be able to open doors. We don't just want to have a blank doorway here. We want to have our AI be able to go through them. And that'll be it for the AI. So 2 more episodes on AI. That'll be it for this episode, and I will see you in the next one. So next, let's make it so our AI can walk through doors, because as you can see, I believe I demonstrated before, I'm going to hit P to show the navigable mesh, and we have this connected strip between the 2 rooms, which means the AI can walk between the 2 rooms. But if we take one of our doors here, and let me just see if I can get this lined up. Actually, almost perfect. Okay. You can see that it is cut off, and because of this, the AI will be stuck in that room forever. So we need to fix this. So let's open up our door actor, and we want to go to our meshes here, and just select one of them, and in the details search for can ever affect navigation. And it's whether the component influences navigation. And we want that to be no. We're going to do it for this mesh as well. So no for both. If we go back into the scene, you'll see that it's now connected again. And if we simulate, you can see our character, once he chooses a room that isn't that one. Seems like he's chosen it twice now. He will just walk, or attempt to walk straight through the door. Now, of course, it's not working because there is collision, so the AI is just kind of floating, trying to get to these rooms, because his AI tells them that it's possible because of this gap here. And we get an error, but that should be fine. So we need him to be able to open the door. And we're going to do this with a trigger box. So I'm going to open the actor again. And we're going to add a trigger box where if he passes through the trigger box, the door will open for him. So let's just go ahead and add component. I'm going to search box collision. And it doesn't need to be huge. I'm just going to kind of fit it to the dimensions of the box first, or the door first. And then I'll just increase that a bit. Okay, so let's create a begin and end overlap for these. So on component begin overlap, and on component end overlap. Now first we want to ask like what actor is overlapping with it, and we only want it to be our AI. This box won't have any function for our character. So off of other actor, we will cast to our, what did we call him? AI classic. So now if this AI classic character overlaps with the box, we'll follow this path, and if it's anything else, it'll follow this path. And we're just going to copy and paste the open door code. So we're going to get this is door closed if statement. Let's just go ahead and copy this dot product stuff as well, even though that'll need changing. And of course, actually opening and closing the door. So I guess, yes, everything after the event interact, we will copy and paste. So once the actor begins to overlap with the box, we will check if the door is closed, and if that's true, then we set it to not closed, and we start to open the door with the dot product to figure out which way we want it to open. Of course, this dot product is referencing our character. We don't want that, so instead of this player ref get actor location, we're going to use the AI classic get actor location. All right, let's keep looking. We have our timeline. It's just called timeline. We can call it open door AI. The lerp should all work the same, and everything else should work the same. Now, if we overlap the door and the door is not closed, we don't want to close it because then it'll close in his face. So instead of this false path coming to here, we want that to come from the end overlap. So once we leave this box, the door closes again. So we will just pull that there and disconnect this false path. We also want to add this branch for the end overlap, so I'm going to copy and paste it. Just pull this out a bit. And we only want to close the door if the door is not closed. So off the false path, is door closed, then we can close the door. Just a extra step of precaution to avoid bugs. Okay, so we can actually test this now and see if it works. So I'm going to simulate once again. So look at our character here. When he overlaps the box, it should open, and when he leaves, it closes again. Perfect. That worked really well. I believe these errors are just because we're simulating and not playing. Just let me double check. See if he goes to the door, just in case that's the issue. Oh. He's thinking. Standing in the doorway, doesn't know which door to go in, and he's made his choice. Yeah, and no errors. Okay, so everything is working as intended. So the only issue we have now is if we try to open or close a door at the same time as an enemy, the code can get confused and not know whether to open or close the door, and it'll try to do everything at once. So I'll see if I can demonstrate. I'm going to try to kind of see what I mean in the back there, how it jumped around opening and closing, and there was a lot of loud noise. So just add a boolean, can interact. We want it to default to true. Off of event interact, before we ask if the door is closed or anything, we just want to make sure we can interact. So if we can interact, if that boolean set to true, then go ahead and do it. If it's false, just don't do anything. And when the AI overlaps the box, to open it, we will set can interact to false, so we can no longer open or close the door while the enemy is inside the box. And then when the door is finished closing after he leaves, then we will want to reset can interact back to true. So off of the timeline, open door AI, off the finished path right here, we're going to switch on the direction of the enum. So just pull off there and switch. Put that in the finished. So when the timeline is done, only if it went backwards, which means the door was closing, we want to set can interact back to true. Okay, so now I'm going to set this to current camera location. So I just start right here by the door. Oh, I got stuck in the ceiling there. When our AI tries to, or comes to the door, not tries to, I'm going to try to open and close it. Oh, and there goes our flashlight. If he's even interested. I think he likes his room this time. Okay. So I'm pressing it, and I couldn't interact with it until it was fully closed again from our AI walking through. So that keeps us bug free and keeps everything looking clean. So our AI is almost completely done for this course. There's just one more thing that we have to get done, and that is right now when you go into a hiding place, such as a locker, they can no longer see you because the locker is in the way, and they will immediately start investigating, which will always end up in them giving up because they cannot open lockers. So going into a locker will always be a failsafe. So we need to make it so if they see you go into a locker, they can still catch you by opening the locker and taking you out. And we are going to utilize Blueprint interfaces for this. So let's go to Blueprints, Interfaces, and let's create a new one. So right click, Blueprint Interface, and we'll call it BPI Player Hiding. And we'll open it up and create this function, and we will name it didEnemySee. And the input it will have is going to be of type BP hide actor. Right now we only have the one, which is the locker, but we want to use the parent so that any hide actor you might create will still can utilize this interface. And we'll call this hide actor. Okay, let's open up our AI controller. So AI classic, AIC classic for AI controller classic. And we're going to add the interface to this controller. So class settings, implemented interfaces, add BPI player hiding. Just now realizing I wrote BPT, so I'm gonna go fix that real quick. Alright, so let's implement the function didEnemySee, and we will come back to this in a minute. First we want to go to our hide actor, Blueprints, actors, hide actors, and open up the master parent. And when we interact with it, so event interact, off this false path, so if we're hiding, if we're not hiding, and we interact with it, then we do the code where we actually start hiding. And before anything, we just want to call interface function. So we will cast to the controller, so cast to AIC classic. Oh, I'm sorry, not this node, but cast to AIC classic class. This is the node we want, and the class we want is classic AIC classic. We will then use get actor of class and call this interface function didEnemySee. So just didEnemySee message. The hide actor will be self. So now every time we go into any hide actor, if we're interacting with it to go into it, the first thing it does is call our didEnemySee interface to our AI controller. And then in here, we will figure out, were they looking, did they see it, etc. So let's go back here, and off of this, we will actually get the blackboard, and we can put in self for target, and we will get a value as bool, and the boolean we want is, let's go ahead and open our blackboard for this. So classic, BB classic, is can see player. So I'll copy and paste for the key name. So we want to know if they can see the player first, and we will just use a branch off of the return value. Then we can just print string on both to see if this works. And we'll see saw player hide and didn't see player hide. And we can actually just test that out. So let's start at the default player start, play, and if we just go into our locker, it says didn't see player hide. Now let's try it again after we see this. it says saw player hide. Now, of course, we didn't implement anything past this, so he will just investigate and then eventually give up. So let's continue. So let's go to our blackboard and let's make another boolean, and we'll call it kill hidden player. And we can go to our behavior tree. It's grayed out. Sometimes you just need to open it manually. Now it's all good. And we need to create a third sequence under our is pursuing player. So we have that right here. And I'm just going to put it in between these two sequence, and we're going to call it kill hidden player. And we need to add a blackboard decorator to this, as always. And we want this sequence to be called if kill hidden player is set, and an observer aborts to both. And then on the other two, we also want to make sure kill hidden player is set to false, so it doesn't get confused on which one to go down. So off of cannot see player, add decorator, blackboard, kill hidden player is not set, abort all, and add decorator, blackboard, kill hidden player is not set, both. Back in our AI controller, off of this true statement, we want to set kill hidden player boolean to true. So I'm just gonna copy and paste these, set value as bool, key name and make literal name, and as always I will copy and paste because I don't trust myself to type it out. And we want to set that to true. So when we do see, or when the enemy does see us hide, what do we want the enemy to do? We want the enemy to come up to, in this case, our locker and open it. So we need a location for our AI to come to, and then we need the locker to open, and then we need our AI to kill us. So the location I'm going to use for him to walk is our exit location right here. Just to make it a little easier, you can add a third location for where you want your AI to walk to. You know what, that actually might be a good idea, just in case you want to make more hide actors, and not all of them will really work for the exit location. So let's actually go ahead and do that. So let's go to content, blueprints, actors, hide actors, BP hide actor, and we can just add a component, and this will be another arrow since we'll have a direction as well, and this will be AI location. Okay, file and save, and then just customize it for each hide actor. So if we go to our locker, viewport, we have our AI location. I want to make this negative 90 degrees. We want it facing the locker. It's right over the, and I'm just going to put it at the same height, which is 288 on the z-axis. And we can just kind of experiment with this, and I'll just try 180 and see how that looks for now. So it's as easy as that. Come back into AI Classic. We will get our hide actors, so we know which hide actor it is. And we'll get AI location, is that what we called it? Yeah, get AI location. Get world location. And then we want to set our target location to this vector. So get blackboard, set value as vector. Key name, let's copy and paste, and the target location will be our AI location. Alright, so let's go to our behavior tree, And when this is called, we want to move to that target location. So we will call a move to. And it's already set to target location, but just double check that it is. After he moves to the location, we want him to rotate to face the locker. And we need a key for this, so go to the blackboard, add a key of type vector. Not vector, get key of type rotator. And we will call this AI rotation. Or, no, let's call it target rotation. And we can create a task to rotate our AI. So new task, BT task blueprint base, content AI classic. It's right here. Let's rename it BT rotate AI. Move it into tasks, and we will get an event receive execute AI. And we need to rotate to our rotation point, or our target rotation. So we actually need our tick for this. So event receive tick AI. And what we're gonna do is actually get our controlled pawn and set actor rotation. The new rotation will be our key target rotation. So we can create a variable and we will call this target rotation key. Make it editable, of course, and it'll be of type blackboard key selector. So we can get and then get value as rotator. Of course, we can't just plug it right into rotation because it'll just snap to that rotation. We want him to turn over time so it looks natural. So we will use a interp2. And the current will be our controlled pawn, get rotation, get actor rotation. And the target will be our target rotation key value as a vector. Delta time can come from delta seconds, and then interp speed can be whatever you want. I'm going to try something like 10, and we'll see if that looks good. So we want to know if our rotation is equal to our target rotation, then we can end it. So we will get control rotation, or sorry, we have to drag that off of controlled pawn. And we just have to ask if it's equal to our target rotation, and we can use a tolerance of 1, and then if that is true, then we can finish execute as a success. Now this should all be working except for the fact that we never set our target rotation to what we want. So let's go back to AIC Classic, and here where we set the kill hidden player bool and the target location vector, we also need to set our rotation. So self get blackboard, set value as rotator, key name will be make literal name, and let's copy and paste. Target rotation, copy, paste, and the rotation we want is the AI location arrows rotation from our hide actor. So we have our AI location arrow, and we will just get world rotation and plug that in, and there we go. We have our key set. So let's go back into our behavior tree and actually add this task. So we called it rotate AI, and we want to make sure the target rotation key is set to target rotation. I'm also going to add a wait node in between the moving and the rotating, which will add a good amount of suspense. So the AI will walk up to the location, wait, let's say half a second, and then turn. So it kind of gives you that half second of, oh, did he find me, or is he just looking around near the locker. And we can actually just test this out. So we'll have to make sure he sees us go into the locker. There we go. And he should walk up to the point and rotate. There we go. Great. Okay, that looks really good. Now we just need him to open the door after he rotates and kill our character. And we need to do some of this code inside our hide actor. So open your BP hide actor, the parent. We're going to add a custom event called enemy found. So which means enemy found our player. And we don't need to do anything in the parent, but in the locker, we need to know what do we want to do when our enemy found it. And for us, we want the locker door to open. So we can go to the event graph. We can add the custom event, enemy found. And we just want to copy and paste the open door code. So off of event interact, we don't want this if statement, but we can go ahead and set can interact to false, and then just grab all of this. And timelines can't be duplicated without having a different name, so we'll just call this AI open door. And this just moves the static mesh 90 degrees, and then it calls the parent interact, which sets the timers and moves the character. Of course, we don't want the character to be moved, so just get rid of that parent interact. We just want the door to open. Now, before we implement this, a problem we can have when the door opens, it can kind of push the AI around if it hits him. So you can fix this by having him stand farther back, but having him stand farther back would make it more unrealistic that he could reach you and kill you. So what we're going to do is just when the AI opens the door here, we are going to disable the collision on the static mesh. So before the timeline starts, I'm just going to take static mesh 1, which is our door, set collision enabled, and we'll just set that to no collision. Cool, so now we just need to call this event when we need it. So let's go to our AI controller, and we'll have our own custom event in here, and we will call it pull out of hiding. And we just want to call the event enemy found from here, but we need to know from which hide actor, so we're going to pull it off event did enemy C, since it'll be the same one, and we'll just call enemy found. Of course, now we just need to call this custom event, and we will do this from the behavior tree. We're getting into a lot of blueprint communications, which can get more difficult with AI, so hopefully you are managing to keep up. So we need a new task for actually pulling the character out of hiding. So new task, blueprint base, go into AI to rename it. Pull out of hiding. Into tasks. And event receive execute AI. Off of owner controller, we want to call pull out of hiding the custom event. So we can just cast to AIC classic. And as AIC classic, we will call pull out of hiding. And then finish execute with a success is true. And since we are casting, we can copy and paste, and if the cast failed, success is false. Cool, so very simple task. We can add this to our behavior tree. So after we rotate the AI, we will call the new task, pull out of hiding. And once we do this, we want to copy and paste this infinite waiting loop. So we can just, since our AI is killing us once again, we just want to use this so that nothing else happens in the time it takes our AI to kill us. So paste that and then just put that in right there. Alright, so let's test it. So now if the AI sees us go into the locker, it should open the locker door. Okay, sure you still see me, go in, and now he should come up, rotate, open the locker door, perfect. Of course, that's the only thing that happens right now. Lastly, we just need him to kill us. I also think maybe he's standing just a little too far away, so we can go into our hide actor locker and adjust this AI location. I'm gonna pull it forward just a couple notches. So let's go into our behavior tree, and right after pull out of hiding, but before we start the infinite loop, we can just call this same kill player task. Kill player, and we don't need to set any keys. And now let's test it with the kill player and with the AI being a little closer to the locker. Okay. Enter the locker. Should now be a little closer, open it, and kill us. Perfect. And game over. We can restart, and look at that. Lastly, we just need to reset kill hidden player to false when our player leaves the locker. If you can see, I'm actually not too positive exactly what will happen, but if our AI sees us go into the locker, now he's coming to kill us, but if we leave again, I think he'll just go straight up to the locker and kill us anyway, even though we've left and we've escaped. We don't want that to happen. So we need to go into our interface, blueprints, interfaces, BPI player hiding, create another function called left hiding spot, compile and save, and then in BP hide actor, we want to call this after we leave our hide actor. So we have our move character custom event. After setting is hiding to false. Oh, sorry, not moved character, finish moving. So finish moving, set is hiding to false before we re-enable our movement. We want to call this new function left hiding spot. So we want to use this same code, get AI, cast to AI class, get actor of class, copy that, bring it here. So finish moving, call the event dispatcher, is hiding false, cast to our AI controller, get actor, but this time we want to call, what do we call it? Left hiding spot. As a message. Okay, so now every time we leave our locker or we leave any hide actor, this interface function will be called. So if we go to our AI controller, it now appears here because we already implemented the interface. So, or right here. So let's right click, implement function, and every time we leave a hiding spot, this will be called. So what we need to do, get Blackboard, set value as bool, kill hidden player, and we want to set kill hidden player to false. So we no longer attempts to kill us when we're in the locker, if we leave. So change that to false. And now if we can enter the locker, and if he saw us enter, he'll open it and kill us. But if we leave the locker before he reaches us, he will just continue to chase us. So now let's test to make sure both those things work. Okay, so we're gonna let him catch us first. Let's enter the locker. Comes up, opens the locker and kills us. Game over. Let's go ahead and restart. And this time, escape in time. So sees us go into the locker, but we leave the locker again. And now he's just chasing us again. Of course, he still caught me because I'm terrible at running away. But alright, we have a successful hiding system where we can hide from our character. And hiding regularly will still work, of course. If he doesn't see us go into the locker, he won't try to catch us. So he didn't see us then. And I don't know where he is at the moment, but he's not coming to kill us because he did not see us enter the locker. So he could walk around in this room and never find us. But if he sees us go into the locker, he will come try to kill us while we're inside. But if we leave in time, he will just continue to chase us. Wait, he got me because I ran out right in front of him. Alright, that'll be it for this episode. Congratulations on finishing your AI character. Hopefully this will really get you started on understanding how AI works. We have a fully fledged horror character that imitates what you see in a lot of indie horror games. Hopefully you can kind of flesh it out, find something to make it a bit more unique, a bit more fun, and make it fit your own game. I will see you in the next episode. To wrap things up, let's create a very simple main menu. We want to do this in a new level, so let's go to Maps. Let's create another level, and we will call it Main Menu. And we can save, open it up. It should be completely blank, completely dark. It's good. We don't need anything in the level because we will just be doing this with UI. So let's go to UMG folder, and let's just create a new widget, and we will call it W Main Menu. And I'm just going to create a pretty simple main menu loadout by adding some text in the center. Alignment 0.5, 0.5, 0, 0. Actually, maybe left top, and then so like 100. And a size to context. Make the text whatever the title of your horror game is. We'll call this Spooky Horror Game. Seems like a pretty good name to me. I'm gonna change the font, make it bold, change the size. Just something very simple. And we're also going to add a couple of buttons to start game, quit game. So I'm going to add a vertical box on the left side. So anchor to left middle. I'm going to make the Y 0.5. Size Y 500. Size X 350. I'm going to add 2 buttons, 1 and 2. I'm going to make them both fill, and maybe add a spacer between them so they're not just stuck together. Okay. Add some text to both. I'm just, going through this very quickly. It's going to look kind of ugly, but this is more about functionality than making this look good, so I'm just going to call this play, make it black so it's easier to see, and this one will be quit. Okay. Now let's select the button for play, scroll down, on pressed, we're going to use a node called open level. And the level we want to open is whatever level you have. Ours is called, if we go to content, maps, horror level. So I'll just type that in. You want to make sure it's spelled exactly correct, of course, or it will not open the right one. So it's always good to double check. And on the quit button, on pressed, we're just going to call quit game. And that'll just close the game. Now, here in this world, for the game mode override, we don't want to just use L1 game mode because it'll use our L1 character, and we have already a HUD, and now we're just falling through the world, an endless black void forever, so we don't want to use that. So we will go into content, game BP, we're going to make a new folder called main menu. We're gonna just create a quick new game mode for this. So blueprint class, game mode, or game mode base is right here. Sometimes I forget. We'll call this GM for game mode, main menu. And we want a player controller, so blueprint class, player controller. I'll call this main menu controller. Now in this game mode we just created, we want to set the player controller class not to player controller or HD player controller, but main menu controller. For default pawn, we're just going to remove it, going to set it to none, and in the game mode override in world settings for this level, we want to set it to GM main menu. So now if we hit play, we no longer are using our horror game player, but we're not using any at all, so there's nothing spawned in the world except that we can just see through the default view. So let's go into our main menu controller, and we want to change a few things. So we want to show our mouse cursor, so mouse, we want to check show mouse cursor. In the begin play, we want to create the widget, so create widget, and then choose main menu. And we want to add it to the viewport. And we want to set our input mode to UI only. Player controller is self. Widget to focus is the main menu widget. And let's test that out. So let's hit play. And we have our awful main menu right here with just the text, the play, and the quit. So if we hit quit, it just closes our window because we've quit the game. And if we hit play, it loads up our level. And we are now playing. If you wanted to spice up a bit, you could add stuff in the background so it's not just a black screen. So you could just add a image in the UI if you want, or you could add something that happens in real time. So maybe if we take our mannequin's idle animation, what's it? It's called idle. Not the blend space. Third person idle. Let's just bring him to 0, 0, 0. Let's add maybe our flicker, BP flickering light. Can't remember which one I like better, the actor or the material that we created. Let's change this to lit so we can see what's happening. Ooh. Don't want to leave him overexposed. Guess I could just turn the intensity down. If we hit play, we're gonna see him? Not really. Let's get a camera in here. 0, 0, 0. And let's position it how we want. 90. Something like this. Maybe put him to the side a bit. Maybe move the light to his other side. Yeah, something like that. Now we also want to add a post-process volume because, like always, now that we have light in the scene, we want the exposure to be turned to 1 and 1, and then make sure it's set to unbound so it affects the entire area. As we can see, now that I've made the intensity too low, maybe something like that. And we could just open the level blueprint, get player controller, set view target with blend. Make sure you have the camera selected, right click, create reference to camera actor. Set that as the new view target, blend time 0, and everything else is fine. So now when we hit play, we should be looking through the eyes of this camera, and this just kind of makes it better. My times are way too high for the min and max, so I'm just going to actually just replace this with our point light. And add the function just because it's a little faster than trying to adjust that. So, okay, and then we have our flicker. We'll set that as our light function material. Perfect. Let's hit play. We now have our flickering light and just a very, very simple background. You can build anything you want in the scene. It's a regular scene like everything else. And as we already tested out, the play and the quit work just fine. Alright, so now we have a cool main menu to go into our game, and when we lose the game, we have a way to restart as well. Of course, you can add buttons for return to main menu and quit. For returning to main menu, you would just use this same open level node, but instead of horror level, it would be main menu, and then quit would be the same thing, quit game. Alright, so that's going to be it for creating a very simple main menu. I will see you in the next episode. Congratulations on making it to the end of this course. You should now have the programming knowledge to construct your own horror game with solid mechanics and good structure. Assuming you already have the idea of what kind of story you want your horror game to be, your next step would be to populate your world with assets and pick and choose what mechanics will take part in your game. You should feel confident enough to even take these mechanics and make tweaks to make them better fit your game, or even implement completely new ideas. I hope this course has granted you the ability to move forward on your game, and I'm excited to see what your creative minds output from here. If you want more UE4 tutorials, I put up free ones on my YouTube channel at youtube.com/cobdev. And check out my How to Create a First-Person Shooter course, which covers a broad spectrum of other Unreal Engine capabilities. I hope you enjoyed your time with me, as I certainly enjoyed teaching you. Always remember to keep pushing yourself, and I'll see you later.